yesterday we went over when I gave you an equation, you had to come up with all the answers to it. What they can also do is give you information and make you get an equation from a word problem as well. Yay. So my suggestion to you would be to always draw it out first, whatever the heck it is, and then try and make your equation from there. So the Ferris wheel. We remember, again, that Ferris wheels do not just sit on the ground. It's not a wheel of a vehicle. It is a Ferris wheel. So the Ferris wheel has a radius of 10. So we draw our little center, possibly in the center, it's a little bad. And then we have a radius of 10. So this is 10, this is 10. Okay? Now what's the radius of a circle? What's the radius of a circle? What could you call it on an equation of a sine or a cosine graph, possibly? If I went to draw this, it would go from down here to up here to down here to up here, and I'll draw it properly over there. So the radius is 10 and 10. What's another way of saying that? Amplitude. So, might want to write this on your formula sheet if you're going to forget this. Like, remember, 1 revolution means a period. Radius is the same as the amplitude. And the amplitude gets you the A value, right? We don't know if it's positive or negative, but it gets us an A value nonetheless. Okay. So, we have a radius of 10 at the very least. It rotates every 40 seconds. What's that? When it rotates and does one rotation? Yeah. Yes. So one rotation or one revolution is the same as the period. So we know the period is 40 seconds because it's how long it takes to repeat itself. 4D seconds. Passengers get on at the bottom. That's good. If not, they're airlifting them and dropping them in wherever they want, but they get them on at the bottom, which is 1 meter above ground level. So this here is 1 meter. So how could I find my midline? Anyone know? Yeah. Add the amplitude to the little basey period part, little thing, deal. 10 plus 1 is 11. Because you want to know where your, this here is at 1, right? This here is at 10, like 10. So this is actually at 11. Because it took me 1 to get me here, 10 to get me to the middle, and the midline is where the middle runs, and my smartboard's a little off, which is fun. So that's at 11. So I know I have a midline at y equals 11. Because that's where it's going to be on the graph. Now, if I want to actually sketch this out, I know every 40 seconds it rotates. And it's easier to sketch this out if you break your circle up into quarters. So I'm going to look at it when I get to here, when I get to here, when I get to here, when I get to here. Okay. I'm going to erase this part because it's not very accurate. So we get on at the bottom. So how many seconds is that? 0. So at 0 seconds, we get onto this Ferris wheel. Now remember, height is always y and time is always x. So at 0 seconds, we're at 1 meter. Why I put a comma there, I'm not quite sure. At 0 seconds, we're at 1 meter. Then at this point, we're actually at 11 meters, right? We're not at 10, we're at 11. We have to go up 1 and 10 more, so we're actually at 11. How long did it take me to get there, though? Heard someone say, yeah. 10 seconds. Because it's 40 seconds divided by 4 means every single one of these is going to take me 10 seconds. So this will be at 10 seconds, I'm at 11 meters. Then at 20 seconds, I'm going to be at how many meters? 21. People will still tell me 20 here. Remember, 1 plus 10 plus 10 is 21 meters. Then at 30 seconds, I'm at 11 meters again. Come back down. And then at 40 seconds, I'm at 1 meter. Now it says graph your height above the ground as it varies during the first 2 cycles. So that's only 1 cycle. I'm going to have to go around again. At 50 seconds, I'm at 11 meters. At 60 seconds, I'm at 21. 70 seconds, I'm at 11. At 80 seconds, I'll be back to 0, right? So 10, 20, 30, 40, 50, 60, 70, 80. Why is it important to draw these? Because if you don't draw it, it's going to be very hard to get your C value. 1, 10, 1, 11, and 21. And this is time in seconds. This is height in meters. So at 0, I'm at 1 meter. At 10, I'm at 11. At 20 seconds, I'm at 21. 30 seconds, I'm at 11. 40 seconds, I'm back down to 1. Not here. At 50 seconds, I'm back up at 11. 60 seconds, 21. 70 at 11. And 80 at 1. So I get a graph like this. Should be more around. Okay? So from all of this, I know my A value is what? 10 plus or minus 10, right? We don't know which one. It's really nice when they actually restrict you to 1. If it's because they'll say A is less than 0 or A is greater than 0, they're telling you if it's positive or negative. My D value is what? My midline. What's my middle line here at? 11. And I'm going to draw my midline. Pretend that's straight. It's not. It should be perfectly horizontal. So that's my midline. My midline helps me if I have to find a sine equation, right? All right. The period is 40. So then B is 40. True? Incorrect. If P is 40, B is not 40. They can't be the same. If it was the same, then they would have labeled them the same. The period is 40. Period P. P is 40. Then therefore B is not 40. Please do not do that, okay? So B equals 2 pi divided by P. So B equals 2 pi divided by 40. So in this case, B is pi over 20. And then my C changes depending on what equation I am finding. So we're going to write out our equations. I'm going to do the cose ones first, just because they're usually the easier ones. So y equals, now, if this was an actual written response on your test, and I didn't say, it just says write an equation, you could write whatever one you wanted. Okay, I would pick negative cose personally, if I had a choice. Why would I pick negative cose? The minimum's on the y-axis, which means there's no horizontal shift. So if I had a choice, I'd pick negative cos. But you don't have a choice right now, so we're going to do all of them. So we're going to do positive 10 cos B, which is pi over 20, x something, plus 11. And then we're going to do y equals negative 10 cos pi over 20, x plus 11. Then we're going to do positive sine, positive 10 sine. Oh my goodness. pi over 20 plus 11 and negative sine. All right. So if we do positive cos, we're going to look for how far what is away from the y-axis. Anyone remember? Positive cos, you look for how far what is away from the y. Yeah. The maximum. So my maximum is here. My maximum occurred when? At 20, even though this is horrible and doesn't look like it. It occurred at 20. My smartboard is like a little off all over the place. So at 20, it used to be on the y-axis. It's now here. So I'm moving to the right. You're always moving from the y-axis. So it's going to be x minus 20. Negative cos, you look for the min and how far away it is from the y-axis, right? How far is the minimum from the y-axis? I talked about this already. It's on the y-axis. So it's moved nowhere, right? So I could go x plus 0, which you are not going to see on the test. You're going to see just x, right? Positive sine. What I need to do is draw my minimum or my median or my midline. Wow, that was really hard to say. And then wherever my median or midline crosses through the graph, I'm going to put little dots. So across through here and here. I'll maybe make them blue so that they're more noticeable. So here and here. These two spots, and yes, you could pick one over here, but I'm just going to go with those ones anyways because it's positive. So those two blue dots are going to tell me for my positive sign and my negative sign how I moved, right? This one has a positive slope going through a little blue dot, and this one has a negative slope going through the blue dot. This blue dot occurs at 30, even though it doesn't look like it because I drew really terrible. And this blue dot occurs at 10. The positive slope is positive sine, so it moved to the right 10. The negative slope is negative sine, so it moved to the right 30. Okay? So for positive sine, we're going to go to the right 10. So it's going to be x minus 10. And for negative sine, we went to the right 30. So it's going to be x minus 30. Find the height above the ground after 15 seconds. Seconds is time, right? So I could plug it in for time or for x here. X equals 15. Or I can plug this into my calculator. Now, which one of these would I prefer to plug into my calculator? The one where I had no transformation. So I'm going to plug that one in. Y equals negative 10 cos. Remember that if the fraction has to be in brackets, pi divided by 20, x plus 11. Plug that in your calculator. What's my window going to be? My x minimum is time, so my x min is going to be 0. My x max needs to at least be 15 seconds because that's what I'm finding. But I'm going to make it be 80 because that's 2 full revolutions. My x scale, I would make be 5. My y minimum is 0 because that would be on the ground. My y max has to be bigger than 21 because that's as high as this Ferris wheel goes. So I'm going to do 22. And my y scale, I'm going to make be 2. Where's the only place we can punch in x? Second, trace, value, x equals 15. What do you get for time? Or what do you get for height, sorry? 18 points, sorry. Now this one's 15 again. So if you don't know which one to plug it in, you're going to be guessing, right? So seconds is time, time is x. Height is meters, so y. Now this says find the times. Now if I say find the times and I don't give you like a limit, you could find a whole bunch of times forever, right? If this Ferris wheel just kept going on forever. So find the times during the first revolution. Let's do during the first revolution. Where it's 15 meters above the ground. 15 is height, so y equals 15. Where's the place I can plug into y? Y equals. So in your y2, you're going to put in 15. If you take out your cose equation out of y1 and just put in 15, you can't find anything. You just have a horizontal line of 15. Okay? So during the first revolution. So what should you maybe limit your x max to be? What should you maybe limit your x max to be? 40, because the first revolution happens in 40 seconds. Then if you limit your x max to 40, you're only going to see where it crosses there. Whoa. So you're going to get two answers. You're going to go second, trace, oops, second, trace, 5. Then enter, enter, enter. It's going to get you one of them. So 12.62 seconds. And then second, trace, 5, move over, drop down. I'm going to push that one. 27.38. Okay. Then I want you to go to 5.3, the tangent function. At 0, tan is 0 because 0 degrees. At 0 degrees, tan is 0 because it would be 1 divided by 0 because tan is y over x, right? At 180, it's also going to be 0 because it's y divided by x. At 45, it'd be root 2 over root 2. Root 2 over 2 divided by root 2 over 2, so it's going to be 1. And at 90, it's going to be undefined because it's going to be 1 divided by 0. You can't divide by a 0. So if we go to our calculator, it might show up. You go y equals clear. Tan x. Mode, I'm going to put in degrees. And zoom trig. This is what a tan graph looks like. So every single time For a tan, if it has been transformed, which we don't transform tans, you're not allowed to in 30-1, which is fantastic. At 90 and 270, and 90, 270, and every coterminal angle after that, so 90, 270, negative 90, negative 270, you're going to get an asymptote because it's undefined there. Because it would be 1 divided by 0 or negative 1 divided by 0, because it's always y divided by x is tan, right? Or sine divided by cos. Sines are y's, cos are x. And it just goes through 0, 0 here, and it does this lovely little swoopy thing. Okay? So this graph, actually, cos and sine graphs, unless they have been stretched, have a period of 2 pi, right? They happened every 2 pi. We said that the basic sine graph and the basic cos graph repeated every 2 pi. Tan graphs repeat every pi. That is different. They will set you up for that. So if you look here, it's between pi over 2 and pi over 2. Between pi over 2 and pi over 2 is a distance of pi. And we know that because it's happening at 90 and then 270 and then back at 90 and back at 270, which is 180 degrees, right? So the period of a tan graph is pi or 180 degrees. So any tan graph, if you wanted to find the period of a graph off an equation, so say it was like tan bx instead, you would, instead of going 2 pi divided by b like we do with sine and cosine graphs, you would go the period equals pi divided by b. Because tan graphs repeat themselves every pi. The only other difference, if we get a negative tan, this is what happens. So here, I'll put the positive tan there. Negative tan x is a reflection in the x-axis, right? So if your graph was going like this part here is actually going to be down here. This part here is actually going to be up here. So our graphs are going to go like this now. I'll make it thicker so you can see. So the thin graph's the original, and the thick graph is the reflection. So they just go downwards instead of up from left to right. They go down left to right because they reflect in the x-axis. So this that's down here is now up. This that's up here is down here, right? So that's your tan graphs. Okay, next page. So we're going over very briefly the period. So we're looking at just the basic tan x graph. The period of the tan x graph is pi. The domain of cos and sine graphs is XER because they keep going on forever. Domain of tan graphs, you have to think about it just like you would a rational function. Remember rationals when you, in grade 11, when you had to state it and see on the bottom you had x plus 3 in your denominator of your rational, like a fraction. Then you'd have x minus 3 as your asymptote. So when you stated your domain, you just say x can't equal negative 3 because it equaled everything else. Same thing here. You're in a state where the asymptotes exist because you'll just say it can't equal those. So the first asymptote we saw on that graph happened at pi over 2, correct? That first asymptote happened at pi over 2. So x can't equal pi over 2. We know that. And x can't equal 3 pi over 2. We know that. So what is that in degrees? X can't equal 90 degrees, and it can't equal 270. We know that off the unit circle even, because it would be y divided by x, which would get me a 0 in the denominator. Well, if we were stating this, we'd have to also state all the negatives as well, right? And this would keep going on forever, correct? And this would keep going on forever. That would be horrible. You actually wouldn't be able to ever be done your homework because you'd literally just have to keep writing numbers and then never go to bed, okay? There's got to be a better way, right? So the domain, you always state, you guys, the domain as a general solution. General solutions where you go like the plus whatever and NEI, right? Remember how we've done general solutions in the past? That's what you're going to do here. So we're going to take our smallest positive, which is pi over 2 or 90. It doesn't matter. It depends on just what domain they're asking for. So you're going to say x can't equal, so x such that x can't equal pi over 2 plus, what's the next one happening? How many later? Every 180, right? What's 180 in radians? Pi. Pi n NEI. Or it can be x such that x can't equal 90 degrees plus 180 degrees NEI. What's the range of a tan graph? Tan graphs kind of just look like this, and they go that way and that way forever. So what would the range be? It goes up forever and it goes down forever. What's the range when you go up forever and down forever? Negative infinity, positive infinity. Or YER. What's the amplitude of a tan graph? Remember, the amplitude is if I take the max and I minus the min and divide by 2, that's the value of that. Or the amplitude is half the distance from the minimum to the maximum. Like if I take the min, the max, and I add them up and I divide by 2, that gets me my amplitude. Tan graphs go on forever. Can I find the maximum and the minimum and then divide by 2? No. So what's the amplitude? Not applicable. There isn't one. It goes on forever. What's the equations of the vertical asymptotes? The exact same thing as your domain, except it equals them instead of doesn't equal them, right? Your domain, it can't equal those. Your asymptotes, it's asking you, where are they? Well, they're here. They're equal to those. So your domain and asymptotes is exactly the same, except domain is it can't equal those. Your asymptotes, that's what it does equal, are those asymptotes. So your domain, or your asymptotes would be x equals pi over 2 plus pi n NEI. And or x equals 90 degrees plus 180 degrees NEI. We have to answer all the stuff about tan graphs, but we don't actually have to transform. You don't have to state any like horizontal stretch, vertical stretch, anything like that about tan graphs. Which is nice. Okay, what I want you to do, we've done all of those already before, is go to the, there should be an assignment somewhere on here. Where the heck is it? There it is. Here it is. So this is the assignment for tan graphs. 262. It's at the very end. And then there's an assignment for the previous one. So go back to the previous where we ended up. The Ferris wheel question. Bottom of this one. It's right here. But I'm going to just, you're not going to do that whole thing. Just hold on a second.